Right. Thank you so much for being here today, Dave. Appreciate
Thank you
it.
very much, Elizabeth. Hopefully everyone can see my screen and hear me okay.
Yeah, looks great.
Yeah, brilliant. So when I finally get it to change slide, so who am I? Been working on Postgres since about 1997 or so, so quite a long time now. I'm one of the core team members, but I'm also fairly heavily involved with PostgreSQL Europe and the PostgreSQL Community Association, which is non-profit that looks after all of the project's assets, such as trademarks and domain names. And my the pretty much the original way that I got involved in the project was founding the pgAdmin project many years ago now. Work at pgEdge during the day, and when I occasionally get time in the evenings, play a little bass guitar and like to go fishing at the weekends. So, what are we here to talk about today? AI is the current buzz in the tech industry, as we all know, and there's been a certain amount of discussion over whether you need specialized AI databases and so on for working with AI tools. And the very simple answer to that is no, you don't. Um, as Postgres users, we already have a rock solid database, as you all know, which is highly extensible. And when we add an extension like pgvector to it, we can store embeddings in Postgres. And then we can use SQL queries to query that embedding data extremely efficiently, along with, of course, the normal additional queries we might have on metadata. So searching a particular column for a product name or a version number or a user ID to associate with the embeddings we're retrieving. The one thing that we've really not had up until now, there's been a few attempts at doing bits and pieces here and there, but we really haven't had a true enterprise-ready production-grade set of tools for working with AI agents with Postgres. And that's one of the things that I set out to solve at pgEdge. Um, so we're going to talk a lot about the model context protocol today. We'll cover a few other tools shortly as well, but the primary focus will be on MCP and MCP interfaces. So what is the model context protocol? Um, it was an open standard that was defined by Anthropic, and it defines ways in which AI applications can discover and use external tools. So essentially what it does is it allows the LLM that you're talking to in what internally is a chat loop of messages and responses. It allows the LLM to additionally call tools. And those tools can do all sorts of different things, including working with Postgres if you build them in the right way. So you can kind of think of MCP as being USB, but for AI, allows you to connect LLMs to all sorts of different data sources. Before the talk started here, Elizabeth was asking me if I used MCP for anything else at home, and I do. I have Claude connected to my Ubiquiti network and to my Home Assistant installation that runs all of my automated lights and routines and cameras and so on, and to N8N, which allows me to build workflows to respond to events and do things. And there are thousands probably now of different MCP connectors out there that allow you to do those sort of things, allow you to interact with Google Docs and your calendar and Apple Notes and all sorts. We typically and can easily run MCP servers locally on our own machine. Um, your data doesn't need to leave your environment if you don't want it to. So you don't have to use an MCP server with a service like Anthropic, where data might get shipped to Anthropic servers or to OpenAI's servers. You can use them with other tools as well. So you can run your inference on local platforms such as Olama or LM Studio, for example. You can also go for a much more complex multi-user system where you're running MCP servers on a server that all your users within your enterprise can connect to and use with much more control over what they can and can't access, role-based access controls, all that sort of thing, if you want. So you really have the option. The MCP protocol can work either over standard I/O, so a local tool can talk directly to a local server, or they can run over HTTP, or more likely HTTPS. So I mentioned that I wanted to bridge some of these gaps at pgEdge, and what we ended up coming up with was what we call the pgEdge Agentic AI Toolkit. Now, everything we're talking about today is open source. All the code that comes from pgEdge is released under the PostgreSQL license, so it's about as free and open as you can possibly get. If you choose to use our package repositories, you'll find there are some additional components in there listed at the bottom there or as examples, pgvector, vector called BM25. Those are community extensions. They may have other licenses that are not the PostgreSQL license, but they are open source. So the toolkit is designed to be a sort of pick and choose selection of things that you might want to use in building AI enabled applications with Postgres. So we're going to primarily talk about the MCP server here. The MCP server allows us to work with Postgres. So as DBAs or sysadmins, we can use it to help in our day-to-day work. You probably don't want to expose an MCP server to untrusted end users, simply because MCP in general will give far more access to the LLM to your internal systems and data than you'd probably want to give an untrusted user. If you're building something like a chatbot to provide support or for searching documentation, there was some strange echo there. Yeah, if you're trying to build a chatbot to power a support function or for documentation queries and that sort of thing, what you probably want is a RAG server. And that allows you to build much more secure way of accessing data that's been chunked and had embeddings created within Postgres. So you can run semantic searches over that data, and we'll talk a little bit more about this later on. That will retrieve context for the LLM that can then build its response. Now, because those are very tightly defined pipelines, as we call them, they will typically have access to maybe one table in your database, which is the one containing the information that you want to make available to your end users. So just as a warning up front, if you're going to build something for untrusted users, you almost certainly don't want to use the MCP server for that. You probably want to use a RAG server or something similar. We have a number of other tools that complement these. So the RAG server is very well complemented by our doc loader and vectorizer. So the doc loader extension tool is a simple tool that allows you to load documentation into Postgres. So what that'll do, you give it a documentation source that might be PDF documents, so HTML, SGML, DocBook XML, whatever, and it will convert that documentation into markdown format, strip out things that are not particularly useful when you're chunking and embedding, and then it will load that into Postgres for you along with any other metadata that you want to store at the same time. The vectorizer is an extension to PostgreSQL, so it runs a background worker, and When you've loaded your documentation, the vectorizer will detect that there are new rows in the table that you've loaded the documentation into, and it will automatically break it up into chunks and store that in what we call chunk tables. And then it will generate vector embeddings. So these are representations of that data that enable us then to perform a semantic search over those chunks. When you use that with the RAG server, it'll run a query, it will generate a vector embedding for the query that you've given it, what is PostgreSQL or how do I configure shared buffers, that sort of thing. And then it will do a nearest neighbor search essentially over the vector embeddings that you've got stored, comparing to your query, return the results to the LLM, which can then process that context and generate the answer that you need. We do also have an anonymizer tool in there, which is useful when you're doing dev tests. It allows you to take a copy of your existing production database and just anonymize any PII that's in there for testing and development purposes, just to make sure that you're not exposing developers to actual names and social security numbers and email addresses and so on, which can be pretty handy when you're developing your AI applications. And then, as I mentioned, there are some additional community extensions which you may choose to use instead of the components that we build. They offer similar functionality, but maybe configured in different ways or fit better into certain architectures for your application and so on. So, onto the MCP server. As said on the previous slide, this is going to be the main focus of the talk today. The way this works is that you're running an AI client or an agent. So that could be Claude, it could be Cursor, or it could be any one of a number of different other agents that allow you to interact with an LLM. When you send a message to that, to the LLM, what happens is the LLM will generate a response for you and send it back. Then you send another message and it sends a response and so on. And that's what we call the chat loop. What the MCP server does is allow a way for us to actually call functions, or for the LLM specifically to call functions within that chat loop. So you can send a query to it, the LLM can think about it, it can then choose, instead of responding to you, to respond to call a tool, for example, get the response from that, generate the response that it then wants to send back to you. Or maybe it will call another tool. That, in the case of our MCP server, those tools would generally be calling Postgres and running queries of some description against your database. So the key principle in our design, we want it to be read-only by default. We don't, unless you explicitly want to grant an LLM the ability to modify your database, we're going to try and avoid that. So that's an opt-in option for safety purposes. Yeah, we've all seen the warnings. AI can make mistakes and so on. We definitely don't want that happening on our production databases, of course. We also wanted to make sure that it works with any Postgres instance. So whether you're running on Azure or RDS, Supabase, or running locally, either with an installer that you've downloaded from Homebrew or PostgreSQL.org or wherever, we wanted this to work. And we also wanted to make sure that there are no extensions or modifications to your database required. Sometimes we may build functionality on top of optional things, for example, having a procedural language enabled, but it's not an absolute requirement. If you don't have that procedural language, then you don't lose out on the entire functionality of the MCP server. So you've heard me talk about tools a few times. So these are essentially functions that we make available to the AI. When we build an MCP server, we define an interface to a tool, which is basically JSON that says, this is the tool, this is what it does, these are the inputs you've got to give it. Input one is blah, 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 input two is blah, 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 input three is blah, blah, blah. And what you're going to get back looks like this. Those descriptions are used by the LLM as part of that context so that it can figure out automatically how a tool can help it to satisfy a user query. So typically the LLM, when you ask it something like, please describe my database, it knows from the tool descriptions that are in its context what tools it has available, and it will look for something suitable that sounds as if it can allow it to connect to the database and understand the schema, for example. So you as an end user don't typically um, tell or ask the user to use a tool, although you can do if you want, and the LLM will generally honor that and do what you ask it. The MCP protocol also defines a couple of other uh, things, if you like, interface types, which are resources and prompts. We're not going to go into a great deal of detail on these in this talk. Tools are pretty much the sort of backbone of MCP. But resources are a more lightweight way of accessing more or less static data. Um, so you might make available things like the PostgreSQL GUCs, so what's returned by select star from PG settings through a resource. It's more lightweight. The LLM knows that it, it's basically can be considered static data. We also have prompts, so you can think of prompts as pre-written prompts that you give the LLM that you can invoke. So rather than having to write out a long, complicated prompt each time that says, right, query this table, look for the highest 10 values in this column, and then do this, then that, and then the other, we can define prompts that are basically workflows, and then we can just call that prompt and give it any inputs that we need for the LLM to work through what is defined in the prompt. It gives you a nice standardized way of performing certain operations, and makes it a lot easier because you don't have to remember that great big long prompt every time. So I'm going to run through some of the tools that we make available in our MCP server. Probably the most or one of the most important of which is the get schema info tool. So this is specifically designed to let the LLM discover your data. So when you tell the LLM to describe my database, it's going to see this tool, and because of the way we've worded the description, um, it will generally pick it up and say, right, that's probably the tool I need to fulfill this request. The purpose of the tool, as you can imagine, is to return the structure of your database. What tables do you have? What columns do you have? What are the data types, the relationships, foreign key relationships, and so on between them? And if you've used them, and I strongly encourage you to do so, both for your own documentation, as well as for the fact that it can help the LLM, uh, the descriptions that are stored when you call the comment on SQL. Um, those are great if you're using tools like PSQL or pgAdmin to browse your database schema, but we can make use of them here as well by returning them to the LLM. And that can help it understand what the structure of your database is and what the purpose of a particular column or a particular table is. The tool also does things like it allows us to detect pgvector columns. So the LLM can then understand that, hey, I might be able to do a semantic search on this particular table to find out some additional information. And as I mentioned a moment ago, foreign key relationships, so it can understand the the structural relationship of the schema. How does the order lines table relate to the order table and to the customers table and so on. And all that information helps the LLM really understand what your application does and how it works without you having to tell it. Now we have to be pretty clever here. You've probably heard, if you've read anything about LLMs or worked with them yourselves, about context. So context is the data that's sent with every request to the LLM. So when you're chatting with an LLM, that's actually a stateless operation. So every time you send a new request to the service, whether it's Anthropic or OpenAI or whatever, what you're actually doing is sending all the previous conversation that you've had and the new question you've asked, along with things like system prompts, tool descriptions, and any other data that you've introduced into the conversation. That gets bigger and bigger, obviously, and you'll at some point get to the point where you've hit the maximum amount of context that a request can handle. For Anthropic, that used to be around I think it was 200,000 tokens. Tokens are common split parts of words, so the might be a token, whereas often might be comprised of off and 10 as two separate tokens. Um, when you hit that 200,000 token limit, or actually when you hit 100,000, probably the quality goes down until you get to the point where you've hit the hard limit at 200,000. Some of the modern models can handle up to 1 million tokens, but we have to pay a lot of attention to that. And if you think about working with Postgres databases, we might have hundreds, millions, billions even of rows in tables. We might have tens, hundreds, thousands of tables in our databases, along with tens or even 100 or more columns in each of those tables. So we have to be pretty smart about how we return that information to the LLM so that we don't immediately blow out the context budget. So we go into auto summary mode first of all. So we'll typically just give a list of tables, and then the LLM can look at that and say, right, now give me the schema for this particular table. So it's going to go multiple times around that chat loop, doing more and more queries to learn about the things it needs to know about, whilst ignoring the things that it doesn't think it needs to know about. And probably the next most important tool, the one that's going to come into play a lot once the LLM has already figured out your schema, is query database. So as you can imagine, the get schema info tool is read only, right? It's just going to look at the Postgres catalogs. It's going to return information from those. It's never going to run any update queries. Query database can. As I mentioned before, one of our overriding requirements or concerns is that by default, everything is read only. Um, we make sure that happens in various ways. We have guardrails to detect update queries or anything that we think might have side effects. We automatically force the connection into read-only transaction mode, for example. So we want to do everything we can to force into read-only mode and guarantee that you can't inadvertently update data in the database unless you explicitly say, no, I'm cool with updating this database or having the LLM update this database. It's a dev database, it's a test database, whatever. So I'm going to explicitly say allow read-write transactions on this one. Similar to what I was saying earlier, to minimize the amount of output and the bloating the context, um, we automatically limit the rows. So when the LLM runs a query select star from orders, we'll automatically append limit 101 to that. The reason we do limit 101 is because that allows us then to tell if there is an additional row, which indicates then that there's more than 100 rows of data. We can then give the LLM hints. And so we can say, yeah, here's 100 rows. There is more if you want. Use offset as an input parameter. And then if the LLM decides it needs to, then it can run the query again and say, okay, offset by 100 and give me another 100 rows, please. When it's got enough data, obviously at that point, it can then stop. It might not need anything more than 100 rows to do whatever task you've set it. So we can minimize the amount of tokens that we blast through. We also generally, where it makes sense to do so, return all the results to the LLM in TSV format. Uh, a lot of people think that we sort of use JSON with LLMs all the time, and that's kind of true. That does tend to be the default that you'll often see. But LLMs are more than capable of understanding tab separated values as well. And it's if you think about how JSON is structured, you can immediately see that a tabular format like TSV is way more efficient in terms of not just bytes, but when you break all those different words in the results down into tokens. We also do various other things to try and keep under the token limits and the API usage budgets and so on for the LLMs, such as keeping track of token usage and being rate limiting aware, that sort of thing. The next tool is execute explain. So this allows the LLM to very easily say, hey, here's a query. Can you give me a query plan that this tool, that this would, that would show me how this would be executed within the database server? Um, Anybody who's run Postgres for any amount of time will have undoubtedly run explain many times on their queries, but the plans that you get back, unless you're pretty experienced, they can sometimes be difficult to understand, or maybe they're very large and you just can't comprehend the whole thing in one go. So this allows the LLM to help you with that task because they can understand far more easily what is in that query plan than you or I can. You know, they can process a very large plan much more quickly. And that can then allow us to identify things like missing index or sequential scans which are very, very large, or join issues that are suboptimal and so on. It can also use it to optimize its own queries. So not just to help us optimize what's going on in our applications, but to improve the work it's doing itself. Now, I mentioned earlier, one of the things that the get schema info tool does is detect whether we've got pgvector columns. So the MCP server itself does have a similarity search tool in it, which allows it to do semantic searches across any tables that it finds. There is a caveat to that, which is that you need to be using the correct embedding model. So the MCP server needs to be configured to use the same embedding model that you used when you created your embeddings in your database. But that can be pretty handy if you're building in a knowledge base, for example, into your database. This can allow the MCP server to actually test and work with that knowledge base, not just see the raw data rows that are in your tables. Similarly, like the other tools, we do a few or use a few different tricks to optimize the output, to minimize token usage. And I believe this is the last tool that I'm going to talk about today, which is one of the ones that I personally think is really cool. Um, One of the problems you have with LLMs is they're trained on data on the internet, obviously. They don't necessarily know about a product that was released after their training was completed. And they may only have scant knowledge on Postgres, or maybe they've been trained only on the most recent version of Postgres and not the older ones, which can be especially true if you're running smaller models that you can run on Olama on local hardware, for example. What the search knowledge base tool in the MCP server does is it enables a knowledge base that the LLM can use to understand Postgres or pgvector or pgbouncer or pgbackrest or anything that knowledge base has been populated with information about. So it's think of it as Google for the LLM, but a Postgres-centric Google for the LLM. Um, we provide a database that we maintain, which covers Postgres and pgadmin and all those other things that I mentioned. Basically, everything that you will find on the pgEdge website, which is a pretty good cross section of what you might be using if you're using Postgres in production in an enterprise environment. The LLM, if it knows it's working with a particular version of a particular product, it can filter on those details and so on, and really make sure that it understands that it doesn't end up hallucinating because it thinks it knows about something because it was trained on it, but that it actually does because it's gone and consulted the docs. Um, I think this is pretty powerful, and certainly something I've found very useful, uh, just to improve the quality of the work that's done. So, um, custom tools, resources, and prompts. One of the things that we added to our MCP server is the ability to define custom tools and resources and prompts. So if you have domain specific things that you need to work on in your Postgres database, or you want to really help them understand how to perform a particular function within your application, you can define tools which are you define these as either SQL functions or do blocks in various supported procedural languages. So you can define what the inputs are, you can define what the query or the code is that will be executed, and then what the output is. And then the LLM can call that just like any other tool. What actually happens under the hood is the SQL function, the do block, or the procedural language function is executed in Postgres and the results returned, much as the other built-in tools would do so. Um, Resources, those are, as I mentioned before, they're just static things. So we define those as a predefined SQL query. So you define a resource that is made available to the LLM and the SQL query that's used to return the data. And then the prompts I mentioned. Um, Run this query with the selectivity criteria given by the user. Connect to database foo and run this query. So you define that prompt, connect to database $1 and run the query $2, for example. And it's a very simplistic example, of course, but hopefully illustrates the point. When you want to actually execute that, you're just going to execute the prompt and pass it the inputs that it needs, so the database name and the query. And that can be very powerful as well as for um, working through very specific workflows that you might have in your particular environment. Okay, so can do a little bit of a live demo, as it says on the screen there. What can possibly go wrong? Well, with live demos, pretty much anything. Um, so this is Claude if you've not used it before. So I've Claude here connected as an MCP server. Um, and I can just ask a question just to get started. I have not rehearsed this, by the way, other than just checking the MCP server was connected earlier. So what you can see, there we go. You've connected to quite a few. Current active connection is AI Workbench. Brilliant.
Dave, I
That's
don't think
exactly.
we're seeing your screen if you want to switch to that one.
Oh, we tested this earlier. Clearly, it stopped working. See, I said anything can go wrong in a live demo, right? Um,
Yep, looks
there we
good.
go. How's that? Yeah.
Yep, thanks.
There we go. So this is just connected to one of my local test environments here. Um, can you describe what the purpose of the database is to be? So I'm actually running Claude in the web here, but it's actually connected through an MCP proxy server to an HTTP instance of the MCP server that I'm running locally. So you can see what it's doing here is just it's actually calling the query database tool a number of times to have a look around. There we go. So that's entirely correct. So it's a PostgreSQL monitoring and alerting, an AI-assisted operations platform from our AI DBA workbench. Um, you'll have to take my word for it that I have not pre-prompted Claude anyway on what that database is. Um, but it's been able to figure that out just by looking at the database through the server. Um, so we can use this for all sorts of diagnostics. I'm just making stuff up on the fly here. I'm not even sure if my question entirely makes sense, but we'll see what Claude makes of it. Okay, so I wasn't specific about which database it should have looked at for this, but public.audit logon connection 7, one of the pgEdge database nodes. Um, so you can see there that it's able to figure out what's going on. It can look at Postgres databases and help you with diagnostics. It can go much more deeply into things like that and start recommending configuration improvements and so on. Um, doing that, I'd love to do as a demo, but it obviously takes more time than we're likely to have here to dive in that deeply. If you're not using something like Claude, um, and we actually have both a CLI and a web interface that you can just download and use, uh, all under the PostgreSQL license as well. So this is me connected to our web interface. Fairly standard, you've got the history on the side of different conversations, create a new conversation from there. Um, we're connected at the moment, as you can see, to Postgres 17. So this is the Wikipedia database on my laptop here, Postgres 17.4. And I've got write access enabled. I can choose which database I'm working on here far more explicitly. When we're working with a client like Claude, the only interface we have between Claude and the MCP server is the MCP protocol. However, if you're using our clients, then we can introduce additional controls to that. So we have REST APIs alongside the MCP interface. So this allows us to have much more precise control over what database we're connected to. So rather than letting the LLM choose it, we're explicitly doing that through the UI here, which is using REST API calls to tell the backend server which database we're connected to. Whereas with Claude, because we've only got the MCP interface, we have to make sure that Claude is going to get it right, or Cursor, or whatever other agent you want to use. Various options in here, so we can show activity, so tool calls or turn that on, debug messages, and whether or not we want to render markdown. So a quick query here. So you can see it's called the get schema info tool. 3 tables in the public schema, foo, articles, which is obviously my Wikipedia data, and bar. So at some time in the past, I forget when, I created foo and bar. This is where things get dangerous. Um, so we're picking up that it's going to modify data here. Um, and again, we have more control over this in our own user interfaces. The MCP protocol itself has hints for destructive operations. So tools like Claude Code will sometimes honor those hints, but not always. Whereas we have much more control over that within our own interface to be sure that we're catching destructive operations and giving an option to complete them or not. So hey, it worked. That part of the demo didn't fail horribly. Um, we have the ability to download the chat. That can be quite useful if you just want to store something away as a markdown doc. Uh, and we also have the ability to work with various different AI providers. So Claude, obviously, OpenAI, and Olama. They use 3 specific REST API designs. A lot of other tools use the OpenAI standard, so you can actually integrate with those as well. So I'll go back to my slide deck, having surprised myself that nothing went terribly wrong. So if you want to try this out, as I say, you can download the binaries, jump onto github.com/pgEdge, and check out the pgEdge Postgres MCP repository. You'll find the binaries for the CLI, the server, the web interface, and also a separate one for the knowledge base database because it's pretty large. I think it's about 800 plus megs at the moment on the knowledge base. You don't have to have that if you don't want. Um, you can configure it to run without it, and it will just disable the tool. If you want to use our package repositories, then you'll find support for Debian and Red Hat-based platforms there. You configure your AI client to either use ours or set up the MCP server and the relevant database connection information that you need to your client's config and the MCP server config. As I mentioned before, we support standard I/O and HTTP or stream server event transport modes. So you can connect to remote MCP servers. All this is in the documentation. So if you need to look at the docs, then go have a look at the URL below there. You'll also find on that site Ask Ellie, who is our chatbot, uh, built on top of the RAG server and the doc loader and the vectorizer. Um, I'm personally very proud of that tool. I think it works really, really well. So if you have any questions, just ask Ellie. She's extremely knowledgeable and always keen to help out. And a good example of what you can do with the RAG server. Um, if you want more information on that, you can always check out my blogs on the main website. Uh, Particularly for the RAG server, there's a series of 3 that run through how to build a chatbot. So working with other tools, we work with pretty much any MCP compatible client, Claude Desktop, Cursor, Claude Code, Llama, LM Studio. LM Studio is one of the open source um, model runners that actually uses the OpenAI protocol for its interface. There are others as well, like EXO, for example, which is relatively new and is largely designed to work on clusters of Macs, but it looks pretty cool. I just haven't persuaded our CFO to let me spend 40 grand on Macs yet. One day, hopefully. And you can run with pretty much any Postgres, whether you're on our pgEdge Cloud or RDS, Azure, Supabase, whatever, entirely up to you. There's an example of our CLI tool, so it's similar in design to using something like Claude Code on the desk in the terminal. Provides pretty much the same functionality as the web interface. So if you prefer not to use something like Claude, you can use this and connect it to LM Studio running entirely locally if you wish. We've just seen the demo of the web interface, but there's a good example. This is one that I didn't run because it would probably take 3 or 4 minutes to generate this. But very simple query, analyze my database for potential performance issues, and get a comprehensive report back telling me what appears to be wrong, and I can get it to offer solutions and so on. So, any questions?
Thanks so much, Dave. I'm gonna pause the recording now and folks